Wait, can you tell me what you think of the smell of the tea, Gabe?
It smells like ginger, and I don't like the smell of ginger, but...
Yeah, it's pretty strong.
Yeah, it's very strong.
Yeah, that's what I think as well. Here is the tea, the ginger tea. We're gonna be taste testing it with some of my family members to see what they think of the flavor and the smell, etc. Okay, Mother, I need you to tell me what you think of the smell, taste, and texture.
It smells good.
Okay.
It's the spices. I like the taste of it, but that's because I like honey. I don't know if you would like the taste if you didn't like honey. And the texture is smooth. It doesn't bother me.
All right.
But there are some spices, and that could bother some people, but
Yeah.
it doesn't bother me.
Yeah, you could strain it out if you needed to.
You could strain it.
Yeah.
Exactly.
Okay, thank you. Okay, Dad, I just need you to tell me what you think of the smell, taste, and texture of the tea.
Smell, taste, and texture. Taste is a little bit of honey kind of spice to it. Texture is smooth. There's nothing grainier or anything like that.
Mm-hmm.
Smell tastes kind of like almost a spice to it. Again, that's honey spice text, smell, taste.
Yeah, it's pretty strong, I thought.
Yeah, it's very strong.
Yeah.
I wouldn't say it's like a normal tea. It's almost like a fireball type taste.
Do you like it? It's okay if you don't like it.
Yeah, I would say it's not my favorite.
Yeah, all right, thank you, Dad.
Yeah.
So we've got the stuff here for chocolate chip cookies, and we've got our butter and eggs to room temperature. So and we've got the oven preheated to 375. That's heating up right now. So we're going to start by mixing the sugar, brown sugar, butter, vanilla, and eggs together. Okay, so we've got our ingredients mixed together, the sugar, brown sugar, butter, vanilla, and eggs. And in this situation, we're going to be using non-melted butter. But then for the next batch of cookies, we're going to be using melted butter. So in this situation, it's unmelted, so it might take a little bit longer to mix. So now we have the flour, salt, and baking soda. I sifted it all together right there. And I'm going to add it to the batter and continue mixing for a little while, just to make sure it's nice and fairly smooth, but not overmixed. All right, so we've mixed the dough together and mixed the chocolate chips, so everything's good. So we're gonna put them on the cookie sheet and start getting them baking. And then while we're doing that, we're gonna make this same thing with melted butter though. As you can see, this time we're making the same thing, everything's exactly the same, except like I said, as you can see, the butter is actually melted this time. It's actually bubbling right there, that's interesting. But yeah, so the butter's melted in this situation instead of in the stick form, and we're gonna see how people think the taste and everything is different once these are done. Okay, so we finished mixing together the dry ingredients and the butter and eggs and stuff, the dry and wet ingredients together. And in this situation, it was a lot easier to mix. Just wanted to draw attention to that. It looks about the same. It's maybe a little bit smoother, might be hard to tell. But yeah, we're gonna see if melting the butter had anything to do, like change the flavor or texture or anything along those lines. The thing I wanted to draw attention to is that these are the cookies that were substituted with Crisco instead of butter. And they actually, as you can see, they're quite crumbly. They're probably not gonna turn out great. The Crisco just did not hold the cookies together as well, and so they're a lot more crummy and probably not going to hold together as well, but we'll see how they taste, because they could potentially taste better. I wouldn't expect it, but you never know, so we will see. Okay, so far what's happened is this is the vodka pie and this is the one with the water, and so we've put the apples in the one with the water so far, and I'm about to put the top on this one, the covering, and then we're going to work on this one and make the filling for that. So, yeah, we're getting there. Okay, so the baked goods have been finished, and so what we have here is the different kinds of cookies and the different kinds of pies made of different ingredients. So, in this situation, the yellow plate of cookies is the chocolate chip cookies that were made with not melted butter, And this plate of cookies, which is a little bit less, some of my siblings have eaten them already, are actually made with melted butter, so they're a little bit different. The one biggest difference I can tell with these is I baked them for the same amount of time, but these are a little bit lighter. I'm not sure if that has anything to do with the melted butter, but those are a little bit lighter. And then the sugar cookies are here also. So what I did with these was one of them was made of butter, one of them was made of a butter substitute, which was Crisco. And so these are the ones made of butter, and these are the ones made of the Crisco. And there's like an obvious physical difference. It might be kind of hard to tell on the camera, but these are just a lot more smooth. They're more well held together, and then these are a lot more like crumbly. Like even as I picked that one up, it like crumbled like right there. You see. So these are just a lot more crumbly. I'm not sure how much difference there is in the flavor. I haven't actually checked them yet, but there's a pretty obvious difference between those, and I think the taste will be different also. And then these like look very, very different, and I'm gonna explain that in a second. But this is the one that was made of vodka. This is apple pie made of vodka. This was the one made of water. And when it came to making the crust, there was a significant difference in how well it like held together. With the vodka, wouldn't hold it together almost at all. I managed to get the pie crust to be okay, like it's average, like on the inside or underneath, but then on top, like it dried out so fast that I couldn't even get it to spread out like it did with this one. And then with the water, it was it was a better consistency when I used water, and it was just able to spread out a lot better. Neither of them look fantastic, but I'm not a baker. But the vodka one was just a lot harder to make, and it was a lot more stressful to make, I guess, just because the pie cover on top just wouldn't stretch at all, and it wouldn't really spread out at all. I rolled them out about the same amount and for the same amount of time and tried my best to roll them out, but it was just so much harder with the vodka one. I'm again going to assume that there's a huge difference in the flavor, but I really don't know. I'm going to be asking some of my family members if they taste the difference, smell a difference, etc. Obviously, there's a texture difference with some of them. But yeah, we'll see. Those are the baked goods. All right, so before you taste test them, once you have them, let me know what you think of the smell, texture, and taste.
Okay.
Yeah, so you can try whichever one you want first.
This one, the blue plate, smells like a basic chocolate chip cookie.
Mm-hmm.
A little crispy, but really pretty nice. It tastes pretty good. It's like chewy, but like not too soft, kind of hard.
Mm-hmm.
Yeah.
All right, cool. And how about this one?
They seem a little more well done than the blue plate.
Mm-hmm.
Seems like even more crispy than those. Kind of hard to. Alright. I mean, it tastes basically the same thing as the blue plate, but I don't know why it's got like a little more flavor in this one.
Mm-hmm.
But it's like still a lot more crispy and like harder. And that's just because like it's probably in more, but.
Gotcha. Yeah. Okay, thank you. Okay, so before you taste them, just after you're done, just let me know what you think of the texture, taste, and smell.
Okay. The texture of this one, it has a smooth top, but of course it has the sugar on top. It's crunchy, but in the middle it's like softer.
Mm-hmm.
It tastes pretty good.
Mm-hmm.
It's not like too sugary, but it's good. And yeah.
Does it just smell like regular sugar cookie to you?
Yeah.
Gotcha. Okay, now how about this one?
This one's the same. It has a smooth top.
Mm-hmm.
I like the smell of this one better.
Oh, yeah?
Actually.
Gotcha.
This one is much more dry and crumbly, but I mean, it still has like the same taste pretty much.
Gotcha. Okay, thank you.
Mm-hmm.
Okay, so I've got the two pies here. This one on my right, the left on the camera, is the one that was made with vodka, and this one here on the right or my left is made with just water. So I'm gonna try them and see how they taste. But first of all, with the texture, this one's a lot more smooth. It looks more like an actual pie, quite honestly. That's about it. It's more smooth. It just looks better. It's not as crumbly. This one, on the other hand, is very crumbly. The texture is not very smooth. It's very rough. And I wasn't able to make it look nearly as much like a pie as the other one. And I explained that a little bit earlier. But I'm going to smell them too, just to see the aspect. Okay. Okay, so this one's made of vodka. That's literally the only difference. And it smells like apples, which makes sense. But that's about it. It doesn't really smell like sweet or anything. It just smells like basically just apples. This one though smells very, very sweet. And it smells really, really good. Like I actually want to have this one. This one I'm not too sure about, but this one smells very, very good. It's sweet. It smells like there's like sugar in it, which is good, even though this one also has sugar in it. So yeah, let's see. So I'm gonna try the vodka one first. Oops. I'm gonna try to get some of the crust in the apple. Okay, it wasn't awful. It was mainly really tasteless, honestly. It's not really good at all. It just doesn't really have much of a taste, honestly. I wouldn't really want to eat it, to be honest. It tastes kind of tangy. There's not a lot of flavor. It's a little sour almost. Not really what you're looking for when you make a pie. Okay, now this one. Whoops. Yeah, okay, so this one tastes a lot better. I can kind of tell you like more about the differences now that I have them both. This one was definitely a lot more tangy, the one with the vodka. Not that good at all, very like flaky and dry. This one was a lot less dry. It tasted really sweet. It tasted like a pie. So like this one, I said at first had no flavor. This one is actually just very, very tangy and sour. This one, the one with the water was just sweet. It was really good. This one was definitely a lot better than the one made with the vodka. So yeah. Okay, so in this experiment, what we did was made ice cream with salt, just regular table salt, and rock salt. So this one right here was made with table salt, and this one right here was made of rock salt. And actually, a big difference, and I'm going to explain the chemical reasons later, with the rock salt is that it made it go a lot faster. So this one actually got finished in about, of like putting it in the bag and shaking it with ice. And the rock salt took about 3 minutes and 40 seconds. 3 minutes, 40 seconds, 0.91 milliseconds to be exact. And this one took 4 minutes and 30 seconds. And a few milliseconds, I think 0.23 milliseconds exactly. So this one took a little bit longer, but I'm going to taste test them just to see how I feel about that and like the texture and the smell. So the one that was made with table salt smells like ice cream, smells like a little weird, but not like ice cream I'd want to eat really, but gotta try it. So, and the texture, it's a little weirder than ice cream. It's kind of like a mixture between ice cream and like Jellum almost. I'm not sure, but okay, it's not bad. The flavor's very strong. You can kind of taste the different, you can almost taste the different ingredients almost perfectly. Now the rock salt one, making a little bit of a mess here. The texture, it smells a little bit less strong actually, but the texture is a little bit more grainy from what I can tell, from what it looks like. So let's try this. Yeah, so there's actually a significant difference. So the texture in this one's more grainy. And I think it actually tastes better, but it tastes less strong. This is very, very strong. The one made of table salt. This one's a lot less strong. You can't even almost taste it at first. It almost tastes like ice, basically. But it's a lot less strong, which is interesting. But and it took a little bit less time, so maybe that's actually why. I'm not really sure. But yeah, that's the differences that I could notice in these two. We're gonna get into the chemical reasons for these changes in a bit. Okay, so what I'm going to be doing now is explaining the science behind some of the observations I had or other people had during the experiments that I did after people tasted them and during the process of making them. And I just wanted to clarify that the reason that I'm not showing the actual process of me making the food is just because it was so much. It took a lot of time in order to make this video ridiculously long if I included all of it. So I tried to include the more important aspects of the process of making the food. But that's just the reason that I didn't have all of it in there. But I'm going to be explaining some things now about each specific lab in the order that I chose to perform them. So starting with tea. The tea that we made was, I think, a form of black tea maybe. But it was mainly like ginger tea. It tasted very gingery, very, very hot, spicy almost. And all of the people that I had that tried it, and I tried it, thought it was pretty spicy. My dad definitely thought it was spicy. My mom likes that kind of thing, so she didn't think it was as spicy. But I definitely did not like it too much. It was very hot to me. It really was very strong. One big aspect of tea is actually something called polyphenols, and those are in black tea. And there's a wide range of categories having to do with these polyphenols. And one of the most important polyphenols, sorry, I'm getting tongue twisted here. But one of the most important ones are theaflavins. And these theaflavins are known to kind of contribute to that orange and red color that you get in the tea. That's why when I showed you the tea, it was kind of like a brownish, orangish red, something in that category of color. The reason that those are important, those theaflavins, and polyphenols, is just that they're considered antioxidants, and antioxidants are actually very good for you. Even though there's not a lot of science backing that up, they are good for you and have these health benefits that can really help to protect your cells, and just numerous other health benefits like your cardiovascular health, all of that. That's why you always hear that like tea is a good thing to drink when you're sick. Tea is a good thing to drink just in general, outside of like McDonald's sweet tea, you know. But tea in general is very healthy to drink, especially when you're sick. It really helps you out. It really helps with a sore throat, especially when it has honey in it. So yeah, that's what happened with the tea. That's how the chemistry of that was working whilst I was making it. So yeah. Okay, so the next lab that I did in this situation was the chocolate chip cookie one. And what happened in this lab was there was a difference, not really in the flavor of the cookies, but actually the color. And I made sure I kept them in the oven for the same amount of time, so I'm not sure if maybe my oven was being weird. But the cookies that were made with the melted butter were actually lighter. They weren't as dark, less burns basically. Burns, I didn't really burn them, but they weren't as hard as the ones that were made without melting the butter. And I'm just gonna get into the chemistry a little bit of cookies in general and see if that makes a little bit more sense as to why that may have been, and I'll get into that. But so essentially, when you make the cookies carefully and use all the right ingredients, there's this thing called sodium bicarbonate that's in cookies. Now, you don't know you're putting it in there, but it's there. And when you heat it in the oven, which is where the chemical changes really take place in the cookies, that sodium bicarbonate will actually decompose into water and carbon dioxide, and that's what causes the cookies to rise and kind of become bigger, which is why when you put a cookie about this size on the pan, it will end up being this big. So that's just because when the water and carbon dioxide leave, it goes like this and just causes the cookie to expand, which makes sense. So another thing that happens with this heat that occurs when you're baking the cookies is that it makes the sucrose that's in the cookies, the sugar, break into simple sugar glucoses and fructoses, which gives the cookies their like light brown color. And that's also why when these chemical changes occur, the cookies are able to keep their shape. Because when you take them out of the oven, you'd imagine like the chemical reaction was going on when the heat was happening. But why does it keep going? And that's just because of these breakdowns and chemical reactions that occur, which allow them to stay the same when they're cooked enough. Now, when they're undercooked, sometimes you'll see the cookies or just any baked good in general kind of like collapse in the middle. So that's just when they're undercooked, they're not fully done, and so therefore the chemical reaction can't keep them in their shape the entire time. But even after the cookies are out of the oven, chemical reactions can still occur, chemistry can still become relevant. The humidity just in general, if there's not a lot of humidity in the air, then the cookies, and this makes sense, are going to become harder because they can't really get any moisture. But if they're in a humid area, then they're actually going to be able to pull in moisture and not become as hard. So I'm not 100% sure why maybe the butter made a difference, but I would imagine potentially that since the butter was melted in one and not melted in the other, that the melted butter was able to potentially retain more water, which allowed the cookies to not burn as much in the oven or not become as hard, versus the ones that had the dry butter, which maybe didn't pull in as much water as well. So it didn't get the water vapor inside it. So I think that's a very possible reason that occurred. But yeah, that is the chocolate chip cookie lab. So the next lab was the sugar cookies, and what I did with the sugar cookies was had one with butter and one with Crisco, which is a butter substitute, vegetable shortening is what it's also known as. Butter is very important in making any cookies, but especially sugar cookies, and I'm going to get into why butter is so important in a little bit. But just to start off, flour may be the most important ingredient in any cookie, and that's because of gluten. And gluten is very stretchy, very sticky, and it's a very strong protein that's found in wheat, therefore flour. And it's really necessary to create anything that requires flour, like bread or even like cookies. Now, when the flour gets wet, the gluten activates and starts to become sticky and hold everything together. And that's why when you need stuff, you need bread or need cookies, even cookie dough, it encourages it to form connections with other strands of like proteins, gluten, and just allows it to stick together. That's why bread is so important, because it uses a lot of flour. But cookies and stuff also need that, but not nearly as much as bread does. And that's why we weren't really needing the cookie dough in this situation. But the max heat is 375 degrees. That's what we had it set as. And so the butter in the cookies would begin to melt around like 92 degrees or so. And butter is what we would call an emulsion, which is a mixture of two things that don't want to stay together. And in butter's case, that's fat and water. And that makes sense because when you think about it, fat would be floating on top of water, I believe. I'm not actually 100% sure on that, but I know that they are two things that don't mix well. So as the butter melts, the dough would generally lose its structure. That's why if you were to chill the cookie dough beforehand, it might help because it would be colder to start, and so therefore it wouldn't spread out as much. Now, in the case of the cookies that we made, we didn't use butter in one situation, actually. We used this butter substitute, but I also didn't chill the cookies, so they didn't really stay in their shape very, very well. But I also wasn't trying to keep them in a good shape. If you were making sugar cookies or something for Christmas that are supposed to be in a shape, you might want to chill them so that you can make sure that they stay in one shape, like Santa or something. Now, when the water starts to pull away from the butter, so the water comes away from the fat, it bubbles and is released as steam, and the fat in the butter actually starts to coat the gluten, the flour, and shortens it, which prevents it from forming, or sorry, not forming, growing. And that's why when you have like chocolate chip cookies, which don't use exactly the same ingredients, you have them start at this size and go to this size, versus the sugar cookies, which I put on the pan at about this size, and they stayed about that size, maybe a little bit bigger, but not much at all. And so at around like 144 degrees, after that happens, the protein molecules from the egg that you put in there would uncoil and connect and just really hold that cookie in place. And then at 212 degrees, the water's totally gone, and the cookie would dry out. That's why sugar cookies are a little bit drier than chocolate chip cookies. Now, there's two different ways that you can have cookies rise, and that's yeast and sodium bicarbonate. Sodium bicarbonate is what we used in the chocolate chip cookies. Yeast does a similar thing, but yeast is actually a living thing that reacts with like warm water and starch and sugars. That's why it's used in food a lot, because that's in a lot of food. And when it reacts, it releases carbon dioxide, which has the same effect as sodium bicarbonate, because both are using carbon dioxide. As you remember from before, when sodium carbonate is released or heated up, it makes carbon dioxide and water. So in this case, the yeast releases carbon dioxide, which allows the cookies to rise generally. However, in this situation, that doesn't happen. They don't really rise per se because of what I just mentioned before with the fat and the just the gluten that's used, as well as just the fat and the gluten all mixed together with the butter. But the golden brown color that you find in sugar cookies is actually from something called a Maillard reaction, which occurs at about 310 degrees. So you're more than halfway to the max heat. And this is when proteins and sugars break down and realign into rings. And these rings are what create that golden brown color that you see on the cookies. But yeah, that's the sugar cookie lab. That's the science behind it. Okay, so in the apple pie lab, I think the most important aspect, as I said earlier, was that with the vodka, the pie was very flaky and crummy. It wasn't very good. It honestly tasted bad. And then in the other pie, where water was used in place of vodka, it was actually really, really good. The pie crust wasn't that flaky. It tasted really, really good, honestly. It tasted like a normal pie. Now, to explain why that happened, almost exactly, it's because when you chill the ingredients, which is really, really important when you're making apple pie, that's something I didn't show because it would just be them sitting there in the fridge. But I made sure to chill the pie crusts for quite a while. But what happens when you do that is it prevents the butter in the pie crust from fully melting, which then allows the water in the butter to interact with the gluten in the flour, which is why you get like a less flaky, more bread-like dough. Now, to explain what happened in our situation, what happened when we were using the water was I did everything correctly, and then the water and the butter interact with the gluten in the flour. Now, the reason that the vodka was different was because it was not water, it was vodka. And so instead you would have to substitute vodka in not the vodka in the butter, but the vodka and the butter would interact with the gluten in the flour. Now when the vodka interacted instead of the water, it created a more flaky situation. That's why it just tasted worse. It was more crummy. It didn't hold together as well because vodka just wasn't as good as water in this situation. Now, that's essentially what happened in the experiment, was just that the vodka dried out a lot faster and actually caused the butter to maybe melt or even just harden, honestly. And even when it was being chilled, it dried out. So I had them in the same situation and like covered in saran wrap and stuff, and the vodka one still dried out a lot more than the water one did, and not fully, of course, but there was just a huge difference in just the texture of both of them while making it even. And you could obviously tell afterwards that there was a huge difference in the texture of each pie. Yeah, that's what really happened in the situation with the apple pie, was just that there's this huge difference between the use of the water and the vodka in the dough that just resulted in a more less bread-like dough and more like a cracker almost. Yeah, that's the chemistry behind what happened with the vodka and water difference in the apple pie. So in the ice cream lab, what happened was the difference was table salt versus rock salt. And the reason that the rock salt works better is because it doesn't actually lower the freezing point as much as the table salt does, which means that it actually works faster, basically, than table salt does. And that was seen by the results of the timing of how long it took to shake up the ice cream. It was 4 minutes and 30 seconds about, I don't remember the exact number, I know I said it earlier. It was 4 minutes and 30 seconds about for the table salt versus 3 minutes and 40 seconds for the rock salt. Not a super significant amount, but there is a difference there. Now, something very interesting about ice cream that I found was that milk has lactose in it, which is also considered like milk sugar, which doesn't taste very good. It's not very sweet, even though it's called sugar. The cold in ice cream then tends to numb your taste buds, which again makes sense. So a lot of times people that make ice cream will add a ton of sugar, which I definitely did when making the ice cream, to make sure that you tasted it, because without that sugar, then you wouldn't be able to really taste the ice cream very well because your taste buds would be numb. So I found that very interesting, and that makes sense as to why there's so much sugar in ice cream, because if there wasn't, then you just wouldn't really taste much of anything. So I found that very interesting for sure in the ice cream experiment, and that would be the reason why that difference in the freezing point changing because of the rock salt versus the table salt. That would be the reason for that. What I said earlier, just because the rock salt it's just larger, and it actually has more imperfections than table salt. It's not as processed. So therefore it can actually make that happen faster because it's more natural, and just has the ability to do that. Yeah, that is the ice cream experiment